Matty, when it comes to data centers, what are the key trends out there today?
Hey, Taylor, first of all, good to see you again. So yeah, a lot of activity in the data center space, right? We depend on data centers for all the services and apps and applications that we use. Basically, demand is outstripping capacity, particularly in Europe, right? So in Europe, we always talk about flat B, which is Frankfurt, London, Amsterdam, Paris, and Dublin, kind of the main hubs for data centers. And we see that capacity is outpacing demand based on hyperscale demand and artificial intelligence, right? It's a big driver in the industry as well. So there are a few challenges that come with that. Actually, there's a lot of challenges. Power, access to power, getting that power to a specific location, getting skilled staff, and then there's the increasing regulation and cost to build these facilities, right? So, I mean, wow, data centers have done a lot to be more efficient, and they continue to push the boundaries of efficiency and sustainability. And we actually see that, right? Because it's evolving. You'll know this, right? The average indicator of data center efficiency is PUE, power usage efficiencies. But now more often you'll see WUE. So this is water usage efficiency show up. It's becoming an established metric. So there's all talk about data centers being power hungry, but there's so much work being done to make these as efficient as possible. So in a nutshell, I would kind of summarize it like that.
Now, you mentioned the hype of the current couple of months or 12 months, AI, generative AI. Now, I've been following a lot what the likes of NVIDIA, Intel, Qualcomm, and others. And it's incredible, the capabilities. But one of the things I keep hearing about is that, this stuff is great, but the laws of thermodynamics haven't changed. You need liquid cooling for these future data centers.
Yeah.
What are the implications of this?
Okay, so it's a really good observation, and it is true. When you start by saying that liquid cooling is all the hype, but not all compute will need liquid cooling, right? There's plenty of systems out there that will still use air cooling. It's efficient, it's economic, so it will still be around. But definitely for those high performance workloads and systems, AI being one of them, liquid cooling is definitely the way forward, as it provides the cooling capacity and it does it in a sustainable way. So unlike an average data center floor, you can easily double your capacity in terms of compute and the cooling capacity that liquid cooling provides. But there's a big but, right? Liquid cooling requires a new infrastructure, and there's no prevalent standard for it yet. There's different cooling systems that exist, and they are there for different use cases. So there's things like precision liquid cooling, where you spray a liquid literally onto the chips on the motherboard that get the host, and then it flows down into a tank. There's direct liquid cooling, which is DLC. So you basically provide tubing that goes all the way into your system on a cold plate to your CPU, some of the key components, and it cools it down, it goes to a big heat exchanger that's built in the door at a central location. And then there's immersion cooling for single or dual phase. There's different ways you can do it. But it kind of depends what your needs are and what the workloads are. And these things, I mean, the numbers are insane, right? 100 kilowatt, 200 kilowatt per rack. There's even specifications thinking about, how do we go beyond that? So yeah, liquid cooling is definitely the way forward, as you rightfully say, because the limits of thermodynamics are kind of in reach, right? We need to do something new. It's exciting though, because it's new, but at the same time, a lot of data center operators don't like the idea of liquid cooling on the data center floor, but all the high power circuitry and the networks. It's not always a good mix. So yeah, we have some ways to go here.
Well, I've seen some folks over the past, 10 years with immersion cooling, where they're literally taking what I would call the chassis and dropping it into a pool of liquid. And I'm like, whatever. So the technology exists is fascinating. But I suppose what people need to get or understand, as you said, with liquid cooling, it's cooling on the chip, but then that liquid needs to go somewhere. So you have heat exchangers, you have new piping. It really is really big new infrastructure inside the data center facility, right?
Absolutely. And you need to make adjustments in the data center to be ready for adopting those technologies into the data centers. And right now there is a ecosystem, a growing ecosystem of different vendors and players in the industry that all are developing new systems to tackle some of these requirements. But there's no sort of sweet spot. I think direct liquid cooling is the next natural step. But there are vendors out there that do liquid cooling in some kind of an encasing. So it's kind of like the old blade service where you push it back into a modular system. Or like the piping I just referred to, right? There's a system out there called BlindMate, which is kind of like a garden hose system where you have quick connect and disconnect, like triplets. They connect into each other and then you connect the server. There's tons of innovation out there, but they all come with the benefits, some disadvantages, and there's an associated cost, some infrastructure that needs to be added. Immersion is by far the coolest and the sexiest to look at, right? Because here's a big tank and you drop your server in and there's a specific type of liquid in there. And that in itself is a whole domain. And you get enormous cooling capacity. At the same time though, when you do that, let's say one of your systems has an issue, you need to take that system out. So first of all, you need a crane to do it because you need to vertically lift that thing out there, right? And then you need to let it drip there for a couple of days or maybe a day. It kind of depends on how big your system is before you can take it out. And then who takes care of the warranty? So there are many things that are still out there that are being developed. And it's not just the systems and the liquid. It's a bigger story. But the ecosystem is rapidly evolving and there are some really advanced players. I was working on a project with one of them, a company called Software. They do a lot of advanced innovations in this space. And it's exciting. I mean, for sure, the data center space is always exciting, but I feel like it's turned up a notch by AI and some of these requirements.
No, I've certainly seen it in the work I've been doing. And as you say, I've seen immersion. I've seen people at the Schneider Electrics, the HPE, you name it, right? Everybody's bringing it and it's fascinating. Now, going back, God, probably at least a decade or more, Matty, we were chatting about data centers way back in the day, and we were on about people were saying, look, we're generating all this heat, and it typically just our challenge was to get rid of it.
Yeah.
And then people started looking at, well, can we use it for something else? District heating, secondary heating, whatever.
Yeah.
Given where we're headed with the future, especially AI data centers, is this coming back? Is using that secondary heat a thing?
I don't think it ever went away, to be honest. But it's definitely more at the forefront now than it's ever been because of sustainability, right? So data centers are facing increased regulation, and there's the whole carbon and emissions. I'm not going to dive into that one because, again, that's kind of the domain in itself.
Yep.
So where to start with this? I mean, it needs to be used. That's what we're talking about, right? It's being used more and more by data centers to warm up, particularly, the office space above or next to the data center or the building next door. But we're also seeing an increase in data centers connecting to heat networks. So they can reuse that heat for something like a municipality, city ring, or like there's different ways you could do it, or maybe some fabrication where they need heat. I know of one player that actually puts data centers next to a greenhouse so they can reuse the heat there. So there's all sorts of innovations happening in that space as well. Actually, there's kind of an analogy to our previous topic where this is not fully baked yet, because ideally you want to transfer that heat and you want to find a way where there's a revenue stream or some monetary exchange for that service. It's interesting. I was talking to one data center operator at one time, and he was basically saying, well, a data center is basically a hotel for computers, and we do compute storage and networking, and that's kind of our main product. But you could actually argue that generating heat is also a product of a data center. So how do we productize that? How do we industrialize that? And that question is one that, continues to grow, but also continues to grow in relevance. Again, another space where a lot is happening. Well, I will say GPUs, I'll flip the coin on you a little bit. For data centers to operate efficiently, you also need water for the chillers and the coolers and the cracks and everything, right? Because you need to do the heat exchange. So that typically involves using a lot of drinking water, high quality water. So what we're seeing now is that a lot of these data centers are starting to use grey water, which is basically reclaimed water from, rain or canals. We call water here in the Netherlands, so we love that stuff, right? But that's another way of being more sustainable with water, heat. So again, there's just multiple angles to this. All very exciting. People think data centers are just, dark bunkers that sit in a place somewhere, and but there's a lot of exciting stuff that's happening there.
Well, certainly in my world around the energy industry, and we look at the energy transition, and we look at decentralization, and you've got grid congestion. So big wind farms in the North Sea isn't the answer for everything, but it is a piece of the future. But I am starting to see a lot more people going, hang on a second now, is there anything we can use locally? The microgrid, for want of a better word.
Yeah.
And if we have existing district heating, it's like, what can we plug in there? Because it's back to the sustainability thing. Rather than throwing everything out and starting from scratch with heat pumps or electricity, how can we? So a lot of it would be very, I suppose, location based, local context. But it is an opportunity.
Okay, so we could probably drink a few beers and talk this over. I'll give you one more. So you just mentioned the wind, right? So renewable energy, it's a great energy source, like windmills and solar power. Although the Netherlands is a small country, sometimes up in the north you'd have sun and you have wind, but in the south there'd be clouds and there's no wind. So all of a sudden you have an energy supply in one part of the country, but you don't have that energy supply in another part of the country. So then it's up to the grid, the power grid,
the grid, the transmission operators.
Exactly. So how do you buffer that power? How do you create a buffer somewhere that, if you need to transition that energy, it's actually more local? Who has the capacity or a couple of megawatts to do that? Oh, wait, there's data centers and they all have generators and they all have UPSs. And 99% of the time, these things are, not
sitting around
because it's all redundant, etc. So is there a way where they could use that infrastructure to also monetize it? Because these are big investments. And remember, these big diesel generators, right? They need to be kept standby for when there is a power cut. So there's always diesel being used. So I'm actually going to another energy source now to heat these things. Actually, heat reuse, right? Or the diesel generators is another use case, by the way, that we're seeing. So again, bunch of innovations where data centers, I think, are going to play a bigger role in society than just serving society with digital services. I think they're also going to provide in the future some other services back to society, which is interesting to watch.
Right, grid flexibility is one of the buzzwords here in Europe. The distributed energy resources, another word for it, whatever. And people are looking at data centers, or as you say, large assets around here that can they be plugged in? Right, it's fascinating. But right, if I'm a data center operator and I'm out there and I'm trying to keep my head above water in terms of keeping going, what's going on? There's so much stuff going on. What would be your one call to action for them?
But I'm still biased because I'm working on a project right now, which I think addresses a lot of what we're talking about. So I got a consultancy business. My current client is involved in something called the Open Compute Project. Not a lot of people know about it. I think it's one of the best kept secrets of the data center space. So basically what it is, it's a slightly different form factor for data center infrastructure that addresses the power and the cooling issues that we just talked about. Mm-hmm. It was invented by Meta, formerly Facebook, in 2011. And a lot of the other industry players and hyperscalers are actually using this. I'll give you an example. You just mentioned NVIDIA and the big AI infrastructure, the DGX pods, right? They were actually based on OCP. So it's a different form factor of the rack. There's a busbar that distributes power across these server units, so they don't have individual power supplies. And liquid cooling is integrated through this blind-made infrastructure. So it's all there. The hyperscalers, because of their size and complexity, have seen a lot of these issues already arise, and they've designed an infrastructure for it. So a lot of people don't know about it. If they do, then they're like, well, let's just let the hyperscalers use it. But it's actually open source. It's open compute project. So it's like open source for hardware. You can use this. You can contribute to this. There's a whole community around this. So right now, I'm on a vision to advertise for that a little bit more. But I think it's going to help. I don't think it's going to solve all the issues, right? This is not going to solve world hunger, but it's definitely going to help to mediate some of these challenges. I'll give you an example. Typically, what we're seeing is if you transfer from traditional 19-inch rack to an OCP rack, it's actually the inner form factor is 21-inch, so you get better airflow. Long story. You get about 35% more, a better power efficiency on rack level. That's a lot, right?
That is a lot.
And as I just mentioned, there's a direct liquid cooling de facto standard, which is already provided for in the racks. So you don't have all these different vendors trying different things. You have one thing you can get from different vendors across different racks. So I'm actually quite excited about this because I think it will help accelerate the data center innovation. When you think about it, data centers are super optimized, but they're optimized around the infrastructure. We've never really gone to the heart of the problem, which is the infrastructure itself, the actual servers and equipment that's in the racks. And this does exactly that. So if there's anything out there that I would turn a data center operator to, it's like, just have a look, check it out. And if they're technical, then they switch on pretty quickly. The business people kind of need to get their heads around it, but yeah, that's what we techies do. We sort of piece it all together and explain what we do on calls like this.
Join the dots.
Exactly. Right.
Hey, interesting times. Matty, come here. Thanks for taking the time, and hopefully we get to meet up in the real world one of these days shortly.
We should. Hey, thanks for the time, and thanks for having me.